My name is Joakim, and I work at Nohau Solution in Sweden. And my session is about static analysis. And Matt mentioned a little bit about that you should do that directly after you produce your code. And I will tell you what it is, why to use it, and how to use it. So basically what we have been talking today is a little bit about the tools that Nohau is offering. And regarding the coding, we have a couple of tools supporting the static or using static analysis tool. So I will go through a little bit what they do. And basically why we are here is that software will create a competitive advantage for you. As we see today, software will be, they say they have an expression, eating the world. Everything will be done in software. Of course, not everything, but many features will be done in software. Yesterday in Sweden we have Husqvarna, and they make motors or chains and so on. 10 years ago there was petrol driven and a dead man's grip, all mechanical things. But today it's battery driven, and they have all sensors, so they can stop this dangerous chainsaw very quickly in software, not relying on hardware and dead man's grips and so on. And that will be a competitive advantage for them. So, functional safety, Thomas will talk about that a little bit more in the afternoon, but basically you identify what kind of harm the system will do to mankind, or human beings, not mankind, human beings. And then you try to reduce that and mitigate the risk of that happening. And then you get different seal levels depending on how much hazard you have in the system. So if you're doing a nuclear plant, it will be much higher than you do some chainsaw. So basically, what all the standards, as Matt also mentioned, all the standards recommend two things that I will talk about. That is a subset of the language. So when you develop software, they say that you should restrict the language like C and C++, and not use dangerous contract as typecasting and this kind of thing. And the other thing is to use a static analysis tool. But there is so many static analysis tools on the market, and they do different things. And that's why I'm going to talk about a little bit of this. So what is static analysis? Basically, it's an analysis of the software without running the software, without executing the software. So you have a system that is doing an analysis of your software. And it checks semantic and syntactic. And what's great with this is that you don't need to create any test cases. So if you develop code and then run a static analysis, it will tell you what to fix, and then you develop your dynamic tests and code, run code dynamically. And it's usually a two-phase process. So one thing is when you scan the code and look all the parameters and how it looks like, and then you do something with the result. So basically you can issue some warning that this is broken from some rule, or you can, if this is overriding some memory, or whatever if the tool does or identify. So the analysis itself only gives two verdicts. Either you get a positive verdict, okay, the tool finds something. And that could be a positive, true positive thing. And then it's a real thing, or it could be false negative things. And this is the nature of all static analysis tool, because what you are doing is you are not running your code, so you're making assumption of a code. Can it take this route? Can it take that route? And you're doing approximations. Because if you have a while loop, it will be internally forever. So then you need to stop somewhere, and you do approximation if you're not running the code. So there is always a trade-off of a tool, how much time it will take, how much memory you have, and what to find, and how many, how much noise the tool will give. And there are, of course, different flavors of the tools. Just like we have coffee, we have black coffee in the morning, we have maybe espresso in the evening, and so on. So all the tools are meant for different things. So at Nohau we have tools to check the performance, for instance. So scan the tool and find construct. Okay, this is a bad construct. This is a bad sorting algorithm, and so on, and gives you advice how to change that. But that's nothing to do much with functional safety. But it could be a safety case if your system is not responding quick enough to events. Then we have compliance. If you limit the language, you need to see that you're complying to a standard. I will talk a little bit about the MISRA standard and other coding standards as well. And then we have more sophisticated runtime checkers that checks if you are running out of memory, if you have data races, and this kind of thing, and how they can occur, even if you don't run the code. And the third type of tool that we have is that we have a tool that's checking the contents of your software. They create a bill of material, a software bill of material. Nowadays, we're often using more and more third-party codes, open source code, and so on. And these, as Vladimir told, maybe they put into the, non-critical part, while the FuSA code is running in the critical part, but you still have to know your code. What is your product consist of, and so on. So that is another type of static analysis that we can do with tools from Nohau. So basically, as Ritsan talked about, there is coding standard, and two coding standards made for safe programming. That is MISRA, that is an Motor Industry Software Reliability Association, and they said, okay, if you're using C, you should use it in this way to produce safer code. And the same thing with MISRA C++. I think the current standard for MISRA C++ is 2008, and then in the automotive area, they developed their own standard called AutoSAR C++, and that is based on C++ 14. And now there will be a work merging these standards into one new C++ standard. And for security, we have a lot of cert standards and this kind of thing. But they tell you that this is how you should write your code to get it more secure and more safe. So if you look at MISRA, for instance, this is a rule set, like traffic rules that set up in the traffic. And we should not drive this way. We should not, increase or we should keep the speed limit and so on. So it's basically a way of determining how we should write the code. And if you should be a MISRA compliant, and if your customer requires you to be MISRA compliant, you need, of course, you can deviate from these rules, but then you have to motivate why you deviated from this rule. So the rules are I think, in MISRA 2012 here, maybe 144 rules or something. And some are mandatory, some are required to reach a certain level, and some are advisory. But when you do this, and it mainly looks like this, that you have the rule, why the rule is there, and some coding example. And if you want to deviate from this, you need to specify to your customer why you're or how you deviate from it. And that could be on a company level, a product level, or each individual coding line. So this is very good to have a tool to check these rules. It's the very good thing is that you limit the language, and then you get a safer and secure code. And MISRA is probably the most well-known application or rule set that is used. But it can be quite extensive work to do this on existing code. So most of our customers, when they develop a new thing and it should be MISRA compliant, they start from scratch, basically. They have one working module, but they started to develop the code from scratch because it's quite difficult to get a MISRA compliant code out of existing code. It's same with quality. It's nothing. It's hard to build in afterwards, and also functional safety. It's hard to build in functional safety afterwards. But we have a good tool called QMISRA from QS System, and that could be bundled also with the Cantata. So run these checks first to check the compliance with some standard. And if we look at the standard, there are two guidelines that is more important or hard to achieve. And one is there should be no occurrence of undefined behavior. How do you verify that in C and C code? And runtime failure should be minimized. How should you comply with that rule? And of course, static analysis tool, they check the syntax, and that is more or less violations is easy to find. Compiler, you can have compile that does that. But the semantic part is a little bit more difficult to find. So here you need to maybe do abstraction of a code, make a model, and do some special analysis of the code. And there is a lot of things or tools on the market today. So the lint tools has been on market since the 1970s, and that is a very efficient way of checking very fast. But it gives you a lot of noise if you have used PCLint and so on. It requires a lot of tuning and this kind of thing. And most compilers today, they have so strong checkers that this is not necessary. So if we look at the other side, where we have these model checkers and more advanced static analysis tools, you can do a lot more with them at the moment. So we have another tool called Code Sonar, and basically what you do here is that you put your source code or your binaries into the system. Then you pass the code, and then they create an abstract model of a system, like symbol names, trees, control graphs, and so on. And then they perform different analysis, like race conditions, taint analysis, language checks, and so on. And by doing this, you get a database with all the, warnings or things that you should check before you continue to develop your dynamic test cases. So here we get some warnings about leaks, and that should be investigated before you're starting test cases of that, because this could happen and this could not happen. So it's a good way of looking at it. And we also heard about a little bit of security and safety will overlap in terms of standard. And if we look at source code, there's also a big overlap. For instance, if we make some construction that overrides memory, it will probably crash the system. And that is an issue for both safety, but also security. Because if someone can access the system and do this, we get a denial of a service attack and so on. So from the perspective of a code, this standard will overlap, and these tools will also overlap. So some tools are called static analysis tools, some calls it's compliance tools, and some other tools is called static security testing tools. But basically what they do is the same thing, finding bugs and vulnerabilities in the code. So one thing that is important when you do a FuSA project is that you need to know your code. So there is code that is, or errors that is entered while you're programming, and that is called more or less 0 days. 0 day you enter the code. And then there are end days bugs or vulnerabilities. And that is bugs that has been discovered later on, typically in a component and so on. So if we look at the standards for security, for instance, we have this common standard for weaknesses, and that is things that could be found in the code. And that will lead to some kind of common vulnerability exposures of your code. And this is a standard way of reporting this. So vendors of software, if you find something in your software, you always or mostly report these vulnerabilities to this national vulnerability database. So when you use a component or third party, you can see that, okay, this has this exposure in this version, and you should have patch to the latest version, and so on. So what we see today is that we have software, both that we develop from ourselves. We have source code and we have libraries, and then we do binaries of this, and then we also get binaries from third-party vendors and this kind of thing. So what's important when you need to know your code is what to find in these binaries. So then we have also another tool from Grammatech called Code Sentry, and basically it takes the binary code and it looks what's inside that, and it compare and identify the components that it's consisting of, and comparing that to open source components. So they can say, okay, this is a component for TSL 1.3. What are the security issues in that? It can also be done by if you have a private component database inside your company, that you have a catalog that you have run and have many versions. And you can also, like a cached application database, that means that you can run several versions of your own code on this binary to find what kind of vulnerabilities you have in the code. Of course, your own vulnerabilities will not be exposed if you have not done that by yourself. So you have to build up a register of that. And then you get some SBOM, that is a software bill of material in electronic format, standard format. So this is, how to say, free tools that we are providing at Nohau in the area of static analysis. So when it comes to tools in general, we highly recommend that you use a qualified tool, a certified tool. If this is the way, the time it takes to develop something with a non-qualified tool, and this is, you save a lot of time and effort to use a tool that is qualified. And Thomas will talk about that after lunch. So basically, these three tools we are offering at Nohau in terms of static analysis, and I have some recommendation before lunch here, is that you should look at your safety case. That means, is MISRA, for instance, required from your customer? Then you have one how to say, development process, because then we have to report all the deviations and so on. If you don't have a formal MISRA, how to say, requirement, then I think you should use some rule set anyway. Maybe you should set up some way. This is how we develop. We should not use void pointers. We should not typecast everything, and so on. So have some rules, because it's important. And use a static analysis to check these rules. For instance, CodeZoner is a tool that you can do a lot of own checkers, and then you can just put up the checker set that you have, and very good to do that. And static analysis is no way replacing dynamic testing. It should be done at coding in the CI pipeline and so on. And you can, the better code you put in to your system, the better code and more less effort you need to have to get qualified. And save time and money by using fit for purpose tool. That is qualified tool or certified tools or tools that is recognized by an auditor, because it helps very much if for instance TÜV Syd say that okay, we are using this tool and our colleagues at TÜV Syd has checked this tool that it's fit for purpose, then it's okay. It's much easier to talk to the certification persons. So, just before lunch, any questions?